Hello, I'm Sohan, and I will be talking about my paper titled On the Identifiability of Steering Vectors in Large Language Models, which recently got accepted at the ICLR CAO Workshop 2026. This work studies whether the steering vectors in large language models are actually meaningful or not. The steering methods assume that a direction in the activation space corresponds to a concept like politeness or humor. Our central question is, are these directions uniquely defined or are there many equivalent ones? Activation steering is widely used to control the model behavior without retraining from scratch. People often interpret a vector as the politeness direction or the honesty direction, but this assumes something very strong, that the vector is uniquely tied to that concept. But we show that this assumption does not generally hold. We consider a standard setup. We take a hidden representation at some layer, preferably in the middle layers, and add a steering vector scaled by some alpha. This modified activation is then passed forward to produce model outputs. The goal is to simulate changing an underlying latent persona, for example, like making the model responses more formal or more polite. To analyze identifiability, we use a local linear approximation. The effect of steering on model outputs can be approximated using a Jacobian matrix, JL. So effectively what matters is how this Jacobian actually transforms the steering vector. This leads to a key observation, that is, not all directions in the activation space actually causally affect the model outputs. So the core argument behind the non-identifiability of steering vectors is that some directions lie in the null space of the Jacobian. These are the directions that have a net zero effect on the model outputs. So if you take a steering vector and add any null space component to it, the model behaves identically. This means that multiple different vectors can produce exactly the same behavior in a model. Building on the linear approximation and our null space idea, we arrive at the main theoretical result. Steering vectors are not identifiable. There are infinitely many geometrically different vectors which produce identical outputs. So when we say that this is the politeness direction, we're actually picking one arbitrary vector from a very large equivalence class. A natural next question would be, why does this happen in practice? This is because the hidden space is very high dimensional, but the output behavior lies on a much lower dimensional manifold. So the Jacobian effectively has a low rank. This creates a large null space and therefore many indistinguishable directions. To test this empirically, we run a simple experiment. First, we extract a steering vector using contrastive prompts. Then we generate a random vector orthogonal to it and then add it to the original vector. We finally compare outputs from the original vector v and the perturbed vector v orthogonal across multiple prompts and models. The empirical results we obtain strongly support the theory we discussed earlier. Orthogonal perturbations retain about 95 to 100% of the original steering effect. The effect sizes are negligible and the correlations still remain very high. This is not an artifact of a single model or a single trait, but it holds across different models and different traits that we tested. This implies that even significantly different vectors behave almost identically. Under what conditions does the identifiability hold? Identifiability can be recovered if we add structure to the model. For example, if the latent factors are independent, or if the vector is sparse, or we use multiple environments, or we enforce cross-layer consistency. These structural constraints reduce the ambiguity and help isolate true signals from the model, thereby restoring the identifiability. To conclude, we are not arguing that string vectors are completely unreliable, but we argue that string vectors do work for controlling the model behavior, but the directions that we extract are not uniquely meaningful, because they mix true signal with spurious components. This has wide implications for interpretability, safety, and monitoring, so we should be very careful when assigning semantic meaning or representation to string vectors. I hope you understood my paper fairly well by watching this video. Feel free to read the whole paper by scanning the QR code you can see in the bottom right of this slide. I've also attached some links to the prerequisite materials in the description below. They are optional readings, but highly recommended for you to better comprehend the paper. Thank you and have a very great day. Bye-bye.